Okay, in this video I just wanted to go over the calculator technique to find the solutions to this optimization problem. I've already set up the equations here. We have the objective of this particular problem, which is to find the volume of the box from this net. We want to find the maximum volume. The constraints were that the length is 16 minus 2x, the width is 10 minus 2x, and the height of the box will end up being x. So I've rewritten the objective function using just the single variable x at this point. So the discussion has been whether or not to use the calculus menus inside our TI calculators. And so if we do allow that, which I'm leaning towards now, just want to make sure that we're all on the same page and report the same thing when we do this on our test. So I've set up the calculator, and we'll jump into the calculus menu first because we've basically got three things that needs to be done. Number one, we need to find the derivative of the objective function. We need to find when that derivative is equal to 0, and then we need to perform some derivative tests on that to verify that we found a maximum in this case. So let's start with finding the derivative. Now, one of the neat things that I've just discovered is this, that if we create a graphs page in addition to our calculator page here, we can actually write our function in the graphs page over here, and then that function gets stored for use on the other pages. So I'm just going to type in 16 minus 2x times 10 minus 2x times x. And I don't care what the graph looks like, although that could be used to check our work later. I'm just going to jump over here now and call the calculus menu. So we'll go into menu 4.1. If I ask the calculator to compute the derivative with respect to x, in this spot here, since I've stored my function in the F1 location, I can actually type, escape out of that, I can actually type F1, so I'll type F1 parentheses x, and then this calculator will find the derivative with respect to x of the function built on the variable x. And when we tap enter here, we get a nice result. Now I am using the computer and typing this in with the keyboard, and that probably won't be available to you for the test. So to be clear, if I jump into the menu, option 4, number 1, we can actually call that variable from this key as well, this variable key. We'll select the F1 command and type in our letter X here. We've got the same thing. So when it comes to showing your work on the test, I think I would like to see everything that you had typed on your calculator handwritten out so that I can follow your process here. And so effectively I would handwrite this, but I'd write ddx of F1 x, and then I would type or write out what that was equal to. And in our case, it was 12x squared minus 104x plus 160. And so this line of work effectively will communicate to me that you knew to find the derivative of our function. Now, if you don't use this shortcut, this F1 shortcut, it would be totally fine for you to write this whole thing. You could type this whole phrase into the calculator, or you can write that whole phrase out on the test, and that'd be totally fine. It's telling me the same thing. It's telling me that you know to find the derivative of that objective function. So that's part number 1, calculus with the calculator. And the second thing we need to do is we need to solve for when that derivative equals 0. Now, if you're careful with it on the calculator, you can actually copy and paste like I'm doing here on my computer. So we want to know when this derivative equals 0. So I'm copying the derivative command. I'm indicating that I want to find the solution when it equals 0, and we're going to solve for the variable x. When I bring that over to the TI calculator, it should perform that task pretty directly here. So that solve command is here inside the menu. We'll jump into the algebra menu and choose option 1. I'm just going to try the highlight option here. So I'm going to go up, highlight my derivative command, and indicate that I want that to be equal to 0, and we'll solve for x. And there we have our solutions. Alternatively, if we were in the solve command, we can choose algebra, solve, And if we had highlighted the result from our derivative computation, then we can copy and paste that as well. Indicate that that should be set equal to 0 and that we're solving for x. And it too presents our answer. So on paper, you would write out the command that you typed into the calculator, the solve command, and then kind of provide some sort of indication of what the answers ended up being. So I'm just going to draw a little arrow here, and I'm going to say that x is equal to 2 or x is equal to 20/3. And I think that would be a pretty good representation of how we use the calculator to do the first derivative work on this test. Now we need to do the derivative testing. And so if you're comfortable with using the second derivative, then this would be a good chance for us to use that option in the menu as well. So we'll go into the calculus, but this time we'll choose derivative at a point. We'll build our function on x. We'll test the first value where the derivative was 0. We're going to apply the second derivative to that location. So the notation comes up nicely for us, d squared over dx squared. We want to put the original function in here, so not a derivative function, but the original one. So I didn't have that written up here, but I did store that on the graphs page, so I'll call that. So now I'm asking for the second derivative of the function based on x at the location x equals 2. And there's our second derivative at x equals 2. If I copy and paste this function from before, I can also evaluate this at 20/3. If I wanted a different number, I could just delete it and rewrite the whole thing. But here we are evaluating at 20/3, the other location where the derivative was 0. And we get a positive 56. So as far as the derivative testing goes, I'm going to jump over here and I'm going to indicate that the second derivative, you know what, I wonder if I do this. Let me turn off that. What if we write v double prime at 2? I think that would be fine. But I am actually interested in seeing what you typed into the calculator to get there. So maybe I'll go back and I'll say this instead. D squared over dx squared. So d squared with respect to x. The second derivative at, we use this vertical bar, x equals 2, ended up being 56. Now the number itself doesn't matter, but the fact that this was greater than 0 is important because when the second derivative is positive and we have a first derivative that equaled 0, we found a minimum. But I made a mistake there. When x was equal to 2, we ended up getting a negative 56, which is less than 0, and we found a maximum at this point. Then we can do the same thing for the position at 20/3. So when x was equal to 20/3, we ended up getting the positive 56, which is greater than 0, and we found a minimum. Now from here we can report our final answer, but the reason for this video was just to give me a chance to think out loud and share some thoughts with you before we see each other next. These lines of work that we're showing here, the calculus and the derivative testing, can be completed with the calculator as we're showing. And to provide evidence of your understanding on the test, I want to know exactly how you use the calculator. So without you sharing your calculator document with me, which may be an option too, I'll think a little bit about that, without actually seeing your calculator document, the next best thing would be to write down on paper exactly what you had typed into the calculator so that I can follow your syntax, so that I can follow your process and evaluate your understanding from there. So practice with that today while I'm out, and we'll talk more about it on Tuesday, Wednesday, and hopefully get you ready before the test on Thursday. Thanks for watching.